Hello, my name is Emma B and I work at the British Geological Survey. My presentation is about how a conceptual framework for a prototype government-led regional landslide early warning system in India was developed by the LANDSLIP project. The LANDSLIP research project commenced in 2016 with the aim of developing a prototype regional landslide forecasting and early warning system to help build resilience to hydrologically related landslides in two case study regions of India, the Nilgiris and Darjeeling. The project has worked in consortia with interdisciplinary partners from the UK, Italy and India. Central to the landslide early warning system was a common and shared understanding of its conceptual framework. In other words, what were the components of the landslide early warning system and how did they interact? At the start of the project, it was assumed all partners in the consortium had a shared vision for the landslide early warning system. However, it quickly transpired that there was slightly different interpretation and nuances to this vision, largely depending on disciplinary or organisational background. This initially created disparate working and a degree of disenfranchisement. We therefore needed to agree what our system would look like and who the key actors in the system were. I'll now briefly describe some of the component parts of the conceptual model, firstly focusing in on the part most recognisable to the physical scientists. So the landslide forecasting system requires data, and here I show semi-static information such as landslide susceptibility maps, landslide observation and knowledge from field surveys. The landslide early warning system also consisted of dynamic forecast modelling data products, primarily built on the underlying observational data available. Here I show our regional scale short-range landslide forecasts along medium-range landslide forecast products based on weather patterns. The various data and landslide forecast model products were brought together into a decision support dashboard for interpretation by landslide forecasters. Different models are shown alongside one another in a multi-pane viewer. These data components all formed the top part of our conceptual model. But the aim of the project, and thus our conceptual framework, was to help ensure that the prototype landslide early warning system would create insight from the data and models and lead to behavioural change by recipients of the daily landslide forecast bulletins, so the district authorities. So just viewing the data wasn't enough. Interdisciplinary and interagency working enabled wider thinking about what constituted an effective early warning or landslide forecasting system. Communication flows with on-the-ground users of the forecast information were essential and part of the conceptual model for the landslide early warning system, and a key aspect our social science and NGO colleagues championed. Consequently, a daily forecast bulletin was co-developed, enabling the scientific information to be communicated in a way that was digestible and understood by the district authorities. This bulletin and the standardised operating procedures that enable it to be created and utilised by district authorities were trialled by the Geological Survey of India during the 2020 and 2021 summer monsoons. The result of LANDSLIP's interdisciplinary and interagency collaboration was our landslide forecasting system, which is the foundation for early warning. The forecasting system is illustrated by this conceptual model. So knowing what the users within your system need to create knowledge and turn this into insight for downstream users is fundamental for impact and thus success. For more information about the LANDSLIP project, including access to a series of easy digestible knowledge products, please visit our website www.landslip.org. Thank you very much for listening.